Hello everyone and welcome back to the GCSE math series. Today we're going to be taking a look at repeated percentage change. So let's get straight into it. So repeated percentage change involves applying a percentage increase or decrease multiple times over a period. This is commonly seen in scenarios like compound interest, population growth, depreciation and inflation. And if you are an OG fan, you remember one of my first videos I ever done in this GCSE math series was the compound interest and depreciation topics. So I would advise you to look back at that topic because this will make this video so much more easier for you to understand and digest. So looking at the formula, we have that the final value is equal to the initial value times by our percentage multiplier. And if you remember my compound interest video, you'll remember how we harked on about our percentage multiplier questions. So our percentage multiplier goes as follows: 1 plus the percentage change over 100 to the power of n. Well, yeah, this whole thing is to the power of n. So, looking at an example now, we have a population of bacteria increasing by 10% each hour. The first thing that we need to do before even looking at the rest of the question is to work out our percentage multiplier. So, percentage multiplier is equal to 1 plus our percentage change is an increase, so positive 10 over 100, which is equal to 1.1. That's our percentage multiplier. Now, what is the percentage increase in the population after 3 hours? So, this is a different type of question. They don't give us an initial value, but they want us to work out the percentage increase in the population after 3 hours. So, we're going to have to do 1.1 to the power of 3. So 1.1 to the power of 3 gives us 1.331. And the way we work out the percentage increase is to minus 1. So because 1 is the whole, this is to get us our increase. So minus 1 from this, and we get 0.331. And to put this into percentage form, we times by 100 to say there is a 33.1% increase in the population after 3 hours. Okay, looking at some more questions. What's going on here? Looking at some more questions, it tells us a car worth 12,000. That's our initial value. Then depreciates by 15% in the first year, and then by 10% per year for the next 2 years. So we need to work out the value after the 3 years. First thing I'm going to do is work out our percentage multipliers. So in the first year, we have a 15% decrease, which is going to be 1 minus 15 over 100, which is going to be a percentage multiplier of 0.85 because it's a percentage decrease. Remember that. Our second one is going to be 1 minus 10 over 100 because once again, it depreciates by 10%. So this is going to be 0.9. The way we do this now is 12,000 times by 0.85. This is going to be the value after the first year. So 12,000 times by 0.85 gives us 10,200. Now, by 10% a year after this, we can now apply the next 2 years in one go because the rate of depreciation is absolutely constant. So 10,200 times by 0.9 squared will tell us our value that we need to know after 3 years. And that is the value of our car, £8,262. So a laptop was reduced by 25% and then by 10%. A student claims this is the same as a 35 total discount. Is this correct? If not, what is the actual total percentage reduction? So the way we can do this, well, there's multiple ways to do this. So looking at question 2, it tells us a laptop was reduced by 25% and then by 10%. A student claims this is the same as a 35% total discount. Is this correct? If not, what is the actual total percentage reduction? So the way you can attempt this question is to just assign the value to a laptop. So let's say laptop is equal to £1,000. Okay, now our percentage multipliers are going to be 1 minus 25 over 100, which is equal to 0.75. And our second one is going to be 1 minus 10 over 100, which is going to be equal to 0.9. Now conducting our laptop reductions, we're going to do 1000 times by 0.75 first. So 1000 times by 0.75 gives us £750. Then it said it was further reduced by 10%, so times by 0.9, and we're going to get equal to £675. So the laptop should be worth £675. Now the student has claimed that this is the exact same thing as doing a 35% total discount. Now if we're to do this, 10,000 times by our percentage multiplier of 1 minus 35 over 100, that's going to be times by 0.65. So 1000 times by 0.65 is going to be equal to £650. As you can clearly see, 35% reduction is not the same as 25% and then a further 10%. So we can conclude that the student is incorrect. And the question asks us to work out the actual total percentage reduction. And the way we do this, if I just make some space, is we know that the real final value is 675. So we do 1000 minus our 675 to see how much the laptop has decreased by. So our decrease is by £325. And then we apply a percentage where we work out the percentage over the original amount, the £1,000, and we times by 100. And we get the actual decrease to be 32.5%. Okay, looking at some more questions, it tells us an item was increased by 8%, then again by 112, up by 12% to reach £302.78. So we need to work out the original price. The way we do this is we say with a 12% increase, we look at our I call this just say a bottle of water or a bath of water, and this is at 100% capacity. Now this is telling us that it's an increase of 12%. So in total, this is going to be worth 112%. So 112% is equal to £302.78. Now we need to work out 100%. The way we're going to do this is work out what 1% is worth. So divide both sides of the equation by 112. This is going to give us 1% equal to 2.70. Then timesing by 100, we get that the original price before the 12% increase was £270 33 pence, or 34 pence. So now looking at this, it's telling us that the item was increased by 8%. So we say 108% was equal to our £270 34. Then 1% will be equal to, this will be equal to £2.50. And then 100% will be equal to £250 31 pence. And this was our original price. So in a question like this, we need to always work backwards, first dealing with the 12% and then dealing with the 8%. Okay, it tells us that Charlie invests £2,500 for 3 years. Year 1 at 3%, years 2 and 3 at X%. And she ends with £2,705.36. So we can first off do the first year and say 2,500 times by our percentage multiplier, in this case is going to be 1.03 to the power of 1. So 2,500 times by 1.03 will give us 2,575. Now we can set up the second equation. So we have 2,575 times by our x to the power of 2, which is equal to £2,705.36. And in this case, our x is going to be percentage multiplier. So I'm probably better off writing this as, say, percentage multiplier squared. Right. So to solve for p squared, we need to divide through by 2,575. So let's do that and see what we get. 2,575. We get p squared equal to 1.0506. To solve for p, we need to square root both sides, and this is going to give us p equal to 1.025. Now remember, p represents our percentage multiplier, but we need to work out x as a percentage. And looking back, our formula is 1 plus our percentage change over 100. So we can fill in this equation as 1 plus x over 100 is equal to 1.025. Minusing 1 from both sides, we get x over 100 is equal to 0.025. Timesing through by 100 on both sides, we get x equal to 2.5%. And that is the rate that Charlie was given for years 2 and 3. Okay, that's going to conclude today's revision video on repeated percentage change. As always, please make sure to like, comment, and subscribe, and I'll catch you guys.